7.1 is all about ratios and proportions, so let's first go ahead and define those terms. A ratio is simply a comparison between two numbers, and oftentimes it is written as a fraction, so it looks pretty familiar to you. But there are actually three ways that you can write it. So if we have a ratio of 3 to 4, we can write it 3 to 4. Like I said, it looks familiar to us as a fraction. We can write 3 colon 4, or we can write 3 to 4. All three of those ways say the same thing. The next thing we want to define is a proportion. And basically a proportion is just an equation made up of two ratios set equal to each other. So over to the side you can see an example. A over B equals C over D. So we have a ratio and a ratio set equal to each other. That is what makes it a proportion. And then we have means and extremes, and we'll get to that a little bit later. Those are just kind of the corners there. But another example of a proportion would be something like x over 7 equals 5 over 12. Okay, so let's go ahead and simplify some ratios. And it's just basically like simplifying fractions. You want to find something that goes into both numbers evenly. But the key here is that you have to compare like units. So, in example A, we can compare these, or we can reduce these, we can simplify these, because they have the same units. They are both in centimeters. So as a matter of fact, when we can reduce both of the centimeters or cancel out the centimeters. We can reduce the 60 and the 200 by 20. 20 goes into 60 3 times, and 20 goes into 200 10 times. So our simplified ratio is 3 to 10. Now in part B we have an extra step, because we have inches and we have feet. So let's go ahead and make the feet into inches, because we know that 1 foot is the same thing as 12 inches. So if we have 3 feet, that would be 36 inches. So we're comparing 18 inches and 36 inches. Now, since they are like terms, or the same units, we can simplify. So the inches are going to cancel, and 18 goes into 18 once, 18 goes into 36 twice. So we have a simplified ratio of 1 to 2. Okay, example number 2. Find the measure of AB and BC if the ratio of AB to BC is 4 to 1 and AC is 30. Okay, so this is our key here. The ratio of AB to BC is 4 to 1. So if I put a 4 and I put a 1 here, so that AB is 4 and BC is 1, if we added 4 and 1, we would only get 5, not 30. So let's go ahead and put 4x and 1x there. So if we multiply the 4 and the 1 by a number, then it's going to make this a true statement, but we have to figure out what that number is going to be. So let's use the segment addition postulate, so that we have AB plus BC equals AC. We know that AB is 4x, BC is 1x, and AC is 30 because they gave that to us. Combine like terms here, so we get 5x equals 30, and when we divide we get x equals 6. So if we did plug that back in, 4 times 6 is 24, and 1 times 6 is 6. That makes sense, because 24 plus 6 is 30. So AB is 24, and BC is 6. Okay, so now let's turn our attention to proportions, and we will use the cross product property to solve proportions. So we call this cross multiplying, or some people have learned that this is called the shoestring method, because when we cross multiply, it kind of resembles some shoestrings. So The technical definition is the product of the means is equal to the product of the extremes. And you can review up in the definitions where those means and extremes are, but they're simply just the corners. So when you cross multiply, BC is going to equal AD, so the corners there. So if I had M over N equals S over T, if I use the shoestring method or cross multiplying, I would have MT equals, now let's crisscross the other way, NS. Okay, so let's use this to do example number 3. So we're going to cross multiply or use the shoestring method. So we will have x times 3 gives us 3x, and then if we cross the other direction, we have 5 times 6, which is 30. So now we have an equation that we know how to solve. We simply divide both sides by 3, and we get x equals 10. You are now responsible for the checkpoints. You have 3 checkpoints for this evening.